Okay, unless otherwise stated, a function is assumed to have a domain consisting of all real numbers for which the function is defined. Many functions like linear, quadratic, and exponential functions are defined for all real numbers. And we've seen that earlier, right? So their domain, when written in interval notation, is this thing right here. And another way to write the set of all real numbers is this script R that we've talked about, right? Sometimes a function may have a restricted domain. If the rule for a function and its restricted domain are given, you can draw its graph and then identify the range. Where or why do you think we might use a restricted domain? Why? Why would we restrict a domain? Well, we'll talk about that later, so that'll be just an unanswered question. What, Stephen, you have an idea? Like what?
Real life.
A real life, yeah. Actual situation. Yeah, that's it. An actual situation, a real life situation would be like if you say a store's growth or a store's sales are, according to some function, we'll say X, we'll say the monetary, we'll say 100 or 1,000 times 1.12 to the power of X, and this might represent population growth. Okay, the population amount over time. Well, the reason it's a real world situation and the reason it's a restricted domain, because we might want to say 1,000 is the initial value. And so you're just going forward and you know the population won't increase forever, so you're just going to restrict the domain, because even though the function itself as written has no restriction, real life puts a restriction on it. So that's one reason we would have that. Okay. Here we have, this is kind of a forced restricted domain. And if you look at the last exercise set we did one a little bit like this, didn't we? One or two. And it says, for the given function and domain, draw the graph and identify the range using the same notation as the given domain. So how would we draw this graph? What would you do first? Where do you go?
Plot the -4 and 4.
Okay, so you say mark it right here. Yeah, you can do that. That isn't what I was looking for, but that's true, yeah. Yeah, so mark your y-intercept, right? And then what after the y-intercept? After the rise over run, okay? So we'll rise over run. So Victoria, you know you're getting a 0 in this class so far, don't you? Did you know that, Victoria, you're getting a 0 in this class? No, you're really not. I just tried to scare you. Because I'm trying to cure your hiccups. Okay. So anyway, we have this right here, and we've marked it. Now, are these endpoints included here? Yeah, they are, right? So the thing's going to be like this. And so that's the graph, right? That's the graph of the function with the limited domain. And how do we write the range down? It says use the range for the same notation. So our range is going to be what? How do we find our range out of this thing? Yeah, Stephen? No. Victoria? Luke? Jace? Emma?
Would it be -1 and 5?
So -1, so bracket -1 or bracket -1? Okay, so let's go bracket -1. So Emma says bracket -1. Does that look right to you? I think that looks right, okay. And then you also say, Emma, what, 5 here? Is that right?
Yeah.
And then
How do you
close.
get -1?
Because that's still a mess of,
How do you get that?
you divide the root, so you went down 3 and you left 4. Because the beginning started at -4.
Yeah, and Luke is at a disadvantage. Why is Luke at a disadvantage? What did he miss out on?
Oh, you missed out on the song.
The song, right? The song tells you to do all this, right? So Luke, you missed out on that, but you're going to have a chance to make it up. Okay, so any other questions on that? Luke, that was a good question though, okay? So Victoria, how are the hiccups coming? They're good? A little better? Did you get scared and cured of your hiccups? Did I scare you?
No, because I checked my grades yesterday.
You weren't scared of that? No. Sometimes it's worked. I'll scare people about their grades, cures hiccups sometimes.
Does it really work?
Sometimes it will work. It's just a story, so I try it. But I can't try it again in this class probably. And I might say it anyway. Okay, this one here, example 2, for a given function and domain, draw the graph and identify the range using the same notation as the given domain. So what would you do for this one? So -2. Okay, so Stephen says -2. What happens at -2 and why? Okay, very good. That is our y-intercept, exactly. Okay, and now after the y-intercept, what do you want to look at next? Rise over run. So what's our rise over run on this thing? -1. So like, is that up 1 or down 1? Down, right? Down 1 over 1. So it'll look this pattern here like this, right? So something like this. And yeah. Okay, not the best drawn line, but that'll just have to do for a Thursday afternoon, okay? And we know since we have a line, we're talking about this thing here, right? Okay, what next? What is our restriction on the domain of this? Greater than -3. So let's go ahead and mark our x equals -3 right here. So x equals -3. So that's this dashed line, vertical line right here, right? So greater than -3. So how do we go ahead and adjust this graphed line to be greater than -3? So we erase everything less than -3. And do we do anything right here too?
We already don't, it's not on, it's not equal to -3.
Yeah, so we'll do this, right? There's your not equal to -3. A what? What do we call that? We can call that a hole. I haven't really talked about a hole. Sometimes you call it like an open circle, but it's really a hole. Graphically, you call it a hole. Or you can call it a point discontinuity sometimes. But hole would be actually that's a mathematical term, a hole, where it's like an open point. Okay, so now is this done graphically? Fine, are we done with that? Let's look at our range now for this. Or am I missing anything? What is our range for this? What kind of notation are we going to use? Same type of notation here, right? So how do we make that notation here? Y such that y is what?
Greater than 1, no, less than 1.
Less than 1, right? So here's 1, so y is less than 1. Does that take care of it? I think it does. So I think that'll be our answer here, okay? Okay. I'm going to erase this again. Okay, reflect in part A, how does the graph change if the domain is -4, comma, 4 parentheses instead of bracket -4, -4? Yeah. Yeah, so what that would be is that would look like this, wouldn't it? You'd have to change this to the holes, yeah, right here. So that's what it would look like, right? But otherwise it would be the same, okay? Okay, there would be 2 holes, right? I'll just say holes as endpoints. So it's like a location of a point without a point there being there. Pretty strange, isn't it? In part B, what is the behavior as x increases without bound? Okay, what is our, okay, I erased it, but what is our behavior as x increases without bound? Remember, we're going down this way to the, okay, so it would be as x approaches infinity, f of x approaches negative infinity. So that would be that one, okay? And I'm going to erase these two. Part of the reason I'm erasing them is helps to turn around for the next period. What I want you to do is graph these two, 9 and 10, and we'll go over them. I'll go over them pretty quickly. So just take your hand at those. Okay, let's look at 9. So if we go to negative, looks like our domain is between -6 and 2. So at x equals -6, you can mark that on the, just on the x-axis, or you can draw like I have here. X is equal to -6. And then you can go over here to the right and mark x equals 2. And then you can get your equation here, your function. We can start at y equals 2. And then we would have a slope of -1/2. So down 1 over 2. So right here. And then to go the other direction, we go like this. Up 1 over 2, up 1 over 2, up 1 over 2. So be right here. So the thing would look like this. Does that look like how you had it so far? Pretty well? Okay, what do we do at the endpoints now? What endpoint goes over here at -6? A point or a hole?
One.
Point. Okay, yeah, Luke. Why, Luke? Why is that?
Because it's 4 equals
Equal, yeah. See that equals? And this one over on the right at 2, a hole. So that's what the thing would look like. And it says, same notation. So how would we describe our range for this thing? So inequality notation, what's the lowest y value here?
0.
Looks like 1, right? So 1 is less than y, which is less than 5. Okay? Does that look right? Jace? You see what's going on? You know what, one thing I really find that is strange for me in these problems is, and I don't know if anybody else is struggling with this, but what's strange for me is that in this one over here, the domain, you're starting with this thing here and going to this thing. When you consider range, you start with this thing and go to this thing. Does that confuse anybody?
Wait, what?
So for the domain, you're starting here, okay, and ending here, but your range, you're starting here and ending here. So it's like the order, like this 2 does not go with the 5. The 2 goes with the 1, right? And the -6 doesn't go with the 1, the -6 goes with the 5. So I don't know if that's confusion for anybody, but that's something that I've noticed. Okay, now, let me erase these things here. Oops.
Well, doesn't it not really matter which way you go?
No, it doesn't.
If B2 is greater than X, it's greater than
No, it really doesn't. Convention is that you start with the lowest and on the left and go to highest. I guess if you wanted to, could you write this instead as 5 is greater than or equal to y, which is greater than 1? Could we write it this way? Would this still be a mathematically correct statement here? Yeah, it would be. But this does not follow the lowest number to greatest number convention. All right? Next, this one right here, we have our domain. How do we do this? I guess we'd mark it 3, right? So x equals 3. And then we have 3 halves x minus 1. So here's our minus 1. Then we have 3 over 2, right? And then 3 over 2. So it'll be like this. And then negative 3 over 2. So we're going to be looking like this. Okay, and where do we have our restriction located? At 3, right? And is that going to be a point or a whole? Point, right? So this will be a point right here. And that means all the rest of this is gone, isn't it? Okay, and so that's the graph of the thing. And so how do we go ahead and write the range of this? Well,
Let's see.
make infinity up to, what's the,
Or, yeah, no.
well, that's 3. So let's take, we'll find f of 3 is equal to 3 halves times 3 minus 1, right? We just plugged in 3, so we get 9 halves minus 1. What's 9 halves minus 1? Let me write it as 9 halves minus 2 halves. What is that going to be? Seven halves, right? So that's going to be 7 halves. And so here we go, right? So 7 halves, bracket or parentheses? Bracket. So there we have both of these things graphed, the same place. All right? Questions on those? Okay. This may be, let's see if we want to do one more. Okay, real world situation. Now Stephen mentioned real world situation earlier. So I just want to do, so we might have to restrict the function's domain, right? So here we have a situation where Joyce jogs at a rate of 1 mile every 10 minutes for a total of 40 minutes. So how do we go ahead and analyze that? How can we make an equation or an inequality or draw a graph or what? Pardon me? What did you say? She runs slowly. 1 mile every 10 minutes, that's 6 miles an hour. Yeah, definitely not a competitive cross-country type run. But yeah, 6 miles, that's 6 miles an hour, right? Okay, so 1 mile every 10 minutes, how far did she go? 4 miles? So let's go ahead and just make a little graph of this here, right? So 4 miles is how far she ends up going. So this will be miles over here, right? And here's going to be time, minutes, right? So how many? We have 40 minutes, 10, 20, 30, 40 minutes. And we know she went 4 miles in 40 minutes. And so is this finishing thing here going to be a point or a whole? Be a point, right? Because she actually goes that far, according to it. So what does that look? What does the graph of that look like? Well, it looks like this, right? So determine a domain from the situation. So what is our domain here? What's our domain of this graph? Where does she start out with? 0, right? 0, 40, right? Okay, and what is our range? Or what is Joyce's range? 0 to 4, right? 0, 4 bracket. And does it say, it says determine a domain, graph the function, write a function. We haven't written the function yet, right? So we kind of work backwards. So what is the function going to be? What is our slope of this thing here? 4 divided by 40. 1/10, right? So 10th. So we'll say miles equals 1/10 what? Minutes. Can't get any minutes. Okay, mile equals 1/10. We use different variables. We could say y equals 1/10 x, right? And so there would be a function. So we work backwards to get the function, but it's a restricted domain situation, isn't it? Okay. So anyway, we're going to deal with exercises on these more tomorrow probably. So we'll just kind of stick there.